You ever see a self-driving car just totally get baffled by a plastic bag floating across the road? Or a chatbot that's super helpful 1 minute and then suddenly starts spewing absolute nonsense? Yeah, those aren't just random glitches. They're actually symptoms of a much bigger problem. So today, we're going to dig into what happens when AI steps out of the nice, clean lab and into the messy, unpredictable real world, and why so often things just break.
It's this classic problem that drives data scientists crazy. A model works perfectly on their laptop. I mean, all the tests pass, everything's green. But the second it gets deployed for real users, it falls flat on its face. Why does that happen? Well, that is the big question we're going to answer.
It all starts with something I like to call the laptop illusion. It's that feeling you get when your AI model just seems like an absolute genius, It's acing every single controlled test you throw at it. You feel like you've totally cracked the code. But what's really happening is the real challenge hasn't even begun. So what happens when our little genius model leaves the perfect, pristine lab and enters the wild, what engineers call production? Well, it's chaotic out there. It's full of unpredictable data, weird edge cases, and it's usually where our model has its first and often pretty spectacular failure. Let's break down exactly why.
Okay, so culprit number 1 is something called data pipeline mismatch. Just imagine you train a dog to recognize a specific brand of dog food by showing it the same exact bag over and over and over. But then out in the real world, it sees a slightly different bag of the very same food, maybe the design changed a little, and it gets totally confused. That's pretty much what happens to AI when the data it sees in the wild isn't exactly like what it was trained on. And when this happens, man, the fallout is huge. The model's performance just tanks, its predictions become totally unreliable. In trying to fix it, it can be a complete nightmare, because you're basically hunting for a tiny, almost invisible difference between two unbelievably complex systems.
The second major headache is a lack of reproducibility. This is like having a prize-winning recipe for a cake, but every single time you bake it, a completely different cake comes out of the oven. In the AI world, this means you just can't get consistent results, which makes the whole model fundamentally unreliable. You just can't trust it. So what's causing all this frustrating inconsistency? Well, it's usually a combination of all these little hidden factors. Tiny differences in the data, the way a specific GPU chip runs a calculation, different versions of software libraries. The point is, even a super tiny change in the environment can have this huge cascading effect on what the model spits out at the end. And the final challenge is what happens after the model is out there: weak monitoring. This is exactly like sending your kid off to college and then just never calling them, never checking in. You've done all this hard work to prepare them, but now you have absolutely zero idea how they're actually doing out there in the real world. And yeah, you are basically flying blind. Without good monitoring, a model's performance is absolutely going to get worse over time. It's inevitable. The world changes, right? Data patterns shift. We call this drift. And if you're not watching, you won't even notice it's happening. The model's actual performance just becomes a total black box. Okay, so we've laid out all the ways things can go wrong. Now, how do we start to fix them? Well, it all begins with how we measure success in the first place. And that means we have to move beyond the most common and honestly, the most misleading metric of them all: simple accuracy. And this right here is the perfect illustration of the accuracy trap. I mean, think about it. If you have a model that's 99% accurate at detecting a super rare disease, that sounds amazing, right? But what if it gets that 99% score by just predicting no disease every single time? Well, it's completely, utterly useless. Accuracy by itself can be so misleading. So to get a real picture, we use tools like the confusion matrix. It might sound complicated, but it's really just a simple but powerful grid that shows us exactly where the model is getting things right, and even more importantly, where it's getting them wrong. It breaks down every prediction into 4 categories: true positives and true negatives, which are the correct answers, and then false positives, those are your false alarms, and false negatives, which are the really dangerous misses. And from that matrix, we can calculate much more useful metrics. See, the right metric always depends on the job you're trying to do. For example, if you're building a spam filter, you want high precision to avoid false alarms that might hide an important email. But if you're building a model to diagnose a disease, you need incredibly high recall to avoid missing a real case, because that could be catastrophic. All right, so we've been through the trenches of what breaks today. Now let's look over the horizon a bit. The world of AI is moving at lightning speed, and the next wave isn't just about fixing these problems. It's about unlocking entirely new capabilities we've only dreamed of. The future of AI is really being shaped by three big forces all at once. A constant push for massive scale, bigger models, more data, but also the very real constraints of safety, cost, and privacy, and this huge demand for powerful new capabilities that make AI way more versatile and just easier to use. One of the most exciting frontiers right now is multimodal AI. This is where AI starts to get senses, a lot more like us. We're talking about models that can see, hear, and read all at the same time. They can process and connect information from text, images, and audio all at once, which gives them a much richer, more human-like understanding of the world. And that leads us right to foundation models. You've definitely heard of these. Think GPT-4. These are like the versatile Swiss Army knives of the AI world. They get trained on just incredible amounts of diverse data, and then they can be fine-tuned for a whole bunch of different specialized tasks. They're the powerful building blocks for tons of new applications. Next up is Edge AI, and this is a really cool shift. For years, AI has mostly lived in the cloud, on some distant server. Edge AI flips that script. It's all about running these powerful models directly on your device, like your phone or your car. It's like having a personal AI assistant right there in your pocket, no internet connection needed. So why should you care about this? Well, it boils down to three huge wins for you. First, privacy. Your personal data stays with you. It never leaves your device. Second, speed. You get instant results with no lag. And third, accessibility. All your AI-powered features work even when you're completely offline. And finally, this brings us to what feels like the next frontier, intelligent agents. This is where AI makes a huge leap, from being a passive tool that just analyzes data to becoming an active participant in the world. It's the difference between an AI that can tell you there's a problem and one that can actually take steps to solve it for you. So how does an agent actually think? You can kind of break it down into a simple three-step loop. First, it uses perception to sense its environment and figure out, okay, what's happening right now? Then, using memory and planning, it asks, all right, based on that, what should I do next? And finally, it makes a decision and takes an action to achieve its goal. And the way these agents learn, wow, it has come a long, long way. It all started with simple trial and error in safe simulated video games. Today, AI mostly learns from these massive data sets of human examples. But the future, that's about multiple agents learning together, cooperating and competing to solve really complex problems in the physical world, in things like robotics and manufacturing. So there you have it. We've gone from the laptop illusion all the way to the promise of intelligent agents that can actually do things. So as AI evolves from just being a tool into more of a true partner, I'll leave you with this question. What's the first task in your daily life that you would actually trust an agent to handle for you? It's a question I think we'll all be answering a lot sooner than we think. Thanks for joining me.